Steel hums softly as it meets wood, not powered by electricity, not guided by software. No motors, no screens, no blinking lights. Yet this simple tool, shaped by hand, sharpened by stone, can split oak straighter than many modern machines, last for centuries without replacement, and perform its task with near-perfect efficiency. For hundreds of years, medieval craftsmen built cities, ships, cathedrals, and entire civilizations using tools that many today would dismiss as primitive. And yet, when measured by durability, repairability, efficiency, and purpose, some of these medieval tools quietly outperform the machines we rely on today. This is not a story of nostalgia. It is a story of forgotten intelligence. Modern life is defined by machines. We push buttons and expect results. We plug in tools we do not understand. When they fail, we replace them, not repair them. A modern power tool is fast, impressive, and loud, but it is also fragile. Plastic housings crack, motors burn out, proprietary parts fail, batteries degrade within years. Most modern machines are designed for speed and mass production, not longevity. They assume constant access to electricity, spare parts, and global supply chains. When any one of those collapses, the machine becomes useless. Medieval craftsmen lived in a different reality. They could not afford waste. They could not replace tools easily. They had to understand materials deeply: wood, iron, stone, leather, not as consumers, but as partners in survival. Their tools were extensions of the human body, built to last, built to be repaired, built to work anywhere, and some of them still do. The medieval axe is often misunderstood. Popular culture imagines it as a brutal weapon, swung wildly in battle. But in reality, the axe was one of the most precise and versatile tools ever created. A medieval carpenter's axe was not crude. It was asymmetrical, carefully balanced, and purpose-built. The blade was thin and sharp, designed to slice fibers cleanly rather than crush them. The handle length was calculated to deliver maximum force with minimal effort. The steel edge was forge-welded onto a softer iron body, allowing the blade to remain sharp while absorbing shock. This design is not accidental, it is biomechanical. Modern splitting machines rely on hydraulic pressure and electricity. They are powerful, but slow to set up, expensive to maintain, and useless without fuel or power. A medieval axe in skilled hands could fell trees, shape beams, carve joints, and split firewood with remarkable efficiency. Even today, professional timber framers often prefer traditional axes over power tools for precision work. The reason is simple: an axe does not fight the wood, it works with the grain. The adze is one of humanity's oldest tools, and in medieval Europe, it reached extraordinary refinement. At first glance, the adze looks awkward, a blade mounted perpendicular to the handle. But this unusual design allows unparalleled control when shaping wood. Medieval shipbuilders used adzes to hollow massive oak timbers for hulls. Cathedral builders used them to smooth beams that still support roofs today. Unlike modern planers, which remove material aggressively and uniformly, the adze allows the craftsman to read the wood, adjusting angle, depth, and rhythm with every stroke. It produces no dust cloud. It wastes less material. It requires no electricity. Most importantly, it creates stronger wood. Modern high-speed cutting tools generate heat, which weakens fibers. The adze cuts cleanly, preserving the wood's internal structure. That is why medieval ships survived decades at sea, and why some still lie preserved on ocean floors after centuries. Modern saws are fast. They are also brutal. High-speed blades tear through wood indiscriminately, often burning edges, wasting material, and dulling quickly. Medieval handsaws were different. Their teeth were shaped, spaced, and angled according to purpose. Rip saws followed the grain. Crosscut saws severed fibers cleanly. Each tooth was filed by hand, tuned to the specific wood being cut. This meant less resistance, less effort, more control. A medieval saw did not overpower wood, it negotiated with it. Archaeological studies of medieval timber framing show cuts so precise that beams fit together without nails. The saw marks themselves reveal intentionality, not haste. In an age without electricity, efficiency was not optional, it was survival. Long before electric drills, medieval craftsmen used augers, simple spiral tools capable of boring deep, clean holes through dense timber. Unlike modern drill bits, which rely on speed, augers rely on geometry. The screw tip pulls the tool into the wood. The spiral flutes carry waste upward. The cutting edges shave rather than tear. This means less force is required from the user, and the hole remains clean and accurate. Modern drills can overheat, snap bits, or strip motors. A medieval auger, properly sharpened, can last generations. In traditional timber framing, augers are still preferred for large structural holes because they preserve the strength of the beam. Again, slower does not mean weaker. It often means wiser. The medieval hammer was not designed for speed, it was designed for accuracy. Blacksmiths used hammers with carefully weighted heads and handles shaped to reduce fatigue. Each hammer had a purpose, drawing out metal, flattening surfaces, or striking chisels. Modern hammers often prioritize mass production over balance. Cheap alloys, poorly shaped handles, and disposable construction lead to fatigue and injury. A medieval hammer, by contrast, was often custom-made for its user. The result was a tool that felt like part of the arm. This philosophy, tools shaped to the human body, is something modern industrial design has largely forgotten. Chisels built cathedrals. Stone chisels carved intricate reliefs that have survived centuries of weather. Wood chisels shape joints so precise they still hold without glue. Medieval chisels were forged with layered steel, hard enough to hold an edge, soft enough to absorb impact. They were sharpened constantly, not replaced. Modern chisels, often mass-produced, lose this balance. They chip, dull, or snap. More importantly, medieval craftsmen understood when not to cut. They worked slowly, observing stress lines, grain patterns, and material behavior. Their tools allowed feedback, vibration, sound, resistance. Modern machines isolate us from these signals. When feedback disappears, mistakes increase. Few tools shaped civilization more than the medieval plow. Heavy-wheeled plows with iron shares transformed European agriculture. They cut deep into heavy soils, turning earth efficiently and aerating fields without compacting them. Modern industrial plowing relies on massive tractors that compress soil, destroy microbial ecosystems, and require constant fuel. Medieval plows worked with animal power and human intelligence. They preserved soil structure and fertility. Archaeological evidence shows that medieval fields, when properly managed, remained productive for centuries. Efficiency is not just speed, it is sustainability. Medieval builders erected cathedrals weighing tens of thousands of tons without cranes powered by engines. They used treadwheel cranes operated by human weight. These machines converted slow, steady motion into immense lifting power. Their gears were wooden, yet precise. Their design minimized friction. Some medieval cranes remained in use for hundreds of years. Modern cranes are powerful but fragile. When systems fail, work stops. The medieval crane could be repaired with wood, rope, and iron, materials available anywhere. Resilience was built into the design. Medieval tools succeeded because they obeyed natural laws rather than fighting them. They respected grain direction. They minimized heat. They distributed stress evenly. They favored geometry over brute force. Modern machines often rely on excess energy to overcome inefficiency. Medieval tools relied on intelligence. Recent studies in materials science confirm what medieval craftsmen already knew. Slower cutting preserves strength. Layered metals resist fracture, and feedback improves accuracy. This is not myth, it is physics. Modern machines are fast. Medieval tools are precise. Modern machines require infrastructure. Medieval tools require skill. Modern machines fail catastrophically. Medieval tools degrade gracefully. One replaces the craftsman, the other completes them. The tragedy is not that we advanced, but that we forgot. We do not need to abandon modern technology, but we can learn from medieval wisdom. Choose tools designed to last, not impress. Learn basic maintenance and sharpening. Value feedback over automation. Understand materials before forcing them. In woodworking, gardening, building, and even problem solving, slower methods often produce stronger results. Skill is a renewable resource. Machines are not. Medieval tools were not miracles. They were the result of observation, patience, and respect for natural laws. They remind us that progress is not always forward, and that wisdom can be lost as easily as it is gained. In a world obsessed with speed, these tools whisper a different truth. Strength is not noise, efficiency is not haste, and intelligence does not require electricity. If you found value in rediscovering this lost knowledge, support the journey, like the video, subscribe to the channel, and share it with those who believe the past still has something to teach us. Because some tools were never outdated, only forgotten.